everybody. Can you hear me? Alright, so I just want to give you guys a little bit of an update on my research down at Elephant Mountain. Most of you guys know this pretty well, but you're going to hear it again. Alright, so Elephant Mountain kind of has a multi-species approach. We have bighorn sheep and we have mealyhorn. We're trying to balance the needs of both of those species. Bighorn on one hand, we're kind of trying to increase that population, at least have that population growing, so we can take excess individuals off of there and then translocate them to other areas of the state, just to kind of help with this continued restoration effort. Mealyhorn on the other hand, we're not really looking to increase or decrease that population. It's more of a maintenance kind of deal. We're trying to continue to provide sportsman opportunity. So a little bit different management approach to both of those species, but we still need to balance the needs for both of them. Specifically, looking at carrying capacity, especially carrying capacity of the bighorn sheep. Elephant Mountain can support 160 desert bighorn sheep. But the goal of my project is kind of really unravel that, look into that deeper. We know that carrying capacity is not going to remain constant. Your environmental conditions are not going to remain constant, right? So you're going to have maybe some years that are great rain years, and you're going to have some really good vegetation across that. However, then in other years, you're going to have a really bad drought, where you're just not going to have good vegetation production. So that's going to change the vegetation that's available on the landscape, and then how many sheep or deer you can support off of that. So we want to be able to balance the needs of both of these species, but traditional methods of estimating carrying capacity, you're going to go out in the field and you're going to spend 6 months collecting vegetation data. You're going to have to analyze all that data, run it through all those formulas, and then have your carrying capacity estimate. However, that takes a lot of time. It's expensive. You've got to hire somebody to go do that. You've got to take all that time. And then what if it changes the next year or the next 2 years? So what we were trying to do is find a method that we would be able to use more frequently, and be able to provide that to Texas Parks and Wildlife so they can make their decisions kind of a little more quickly. So kind of building on existing work, there has a study that's been done in 2016 in the Mojave Desert, not the Chihuahua Desert, but desert. And they kind of looked at this already. So they used NDVI, or Normalized Differential Vegetation Index, for assessing diet quality. So what that means is they used satellite imagery. So they took a satellite image and looked at how much green is on that landscape. And remember that we're going to look at that a little bit later. Green doesn't always mean exactly what you need. But they used NDVI and they were able to use it to assess diet quality. So they had 275 fecal samples from 5 different populations over 11 years in this area. They used composite sampling, so meaning that they took individual fecal pellets from multiple different piles to kind of get an idea of the entire population. And they used a MODIS satellite. So we want to build on this. They already kind of found what they needed from it, and we just wanted to kind of expand on it, use it for our purposes. So expanding that idea, instead of using NDVI, we're going to use MSAVI, which is Modified Soil Adjusted Vegetative Index. And so really, it's not too different, but it is more kind of a specialized use for highly reflective soils, such as like what we have in deserts like the Chihuahua Desert. So the image on the left there, that's what an NDVI image would look like, and then the image on the right is what an MSAVI image would look like. I'm not going to go too far into that, but kind of our next deal. So remember, they have about 275 fecal samples. Right now, as of Thursday, I have 778 samples, so we're doing really good. 554 of those are desert bighorn sheep, and then 223 of those are mule deer, and then one time I happened to find a sample from an elk, and so I picked it up just for fun. I don't know if we'll actually do anything with it, but we could. But anyways, so we have 778 samples now. I'm going to keep collecting samples through October of this year, so we'll probably be about 1,000 samples by the time everything's said and done. And then we also needed to do some veg sampling. So we know we're going to try and use satellite imagery to get this answer that we're looking for. However, what are we missing by using satellite imagery versus just doing our vegetation sampling on the ground, right? So I have 2 different kinds of vegetation sampling. I don't know, can you guys see those yellow dots on that screen okay? Okay, so all of those yellow dots are browse exposures. So I went out on the mountain and at all these different little points, at each point within kind of like a 100-meter radius, I tried to find the closest and highest, well, I don't want to browse species as far as primary choice, secondary choice, tertiary choice of both deer and sheep. So within that 100 years, I'd find one of those plants and I'd expose it with chicken wire and rebar. And then really close to that, I would try and find another plant of the same species of about similar size and growth stage, and I would leave that one alone. I wouldn't fence that one in. And so then every year I started kind of like December, and it would usually be about December to January. I would go out and I would conduct browse surveys on those, so just kind of seeing the unlignified growth, so the growth from that year, the new stuff, how much do those plants grow, and then also is that plant browse on or not. So just kind of a good idea, like a browse survey, how are we doing? So I collected data in 2023 and 2024. And then all those black points are all of my vegetation plots. So I have 50 of those as well, spread all around the mountain. And those are just to kind of help us kind of compare our satellite imagery to our on-the-ground stuff. So with those plots, each of those are 30 meters by 30 meters, and I sampled 8 points within each of those plots. At each plot, I stuck a Robel pole in the ground, and then stretched a 4-meter tape out in a random direction. And then along that 4 meters, I looked at what's on the ground, what plants are there, how much of that tape do they take up, just to kind of get an idea of what's actually on the ground. So I sampled those post-monsoon, so when we would kind of have all the growth that we were going to get for that year, so generally around October. And so again, I was looking at standing biomass, so how tall is everything, or how tall is your tallest vegetation, and then what grass species are on the ground and how much of that area do they take up. And then again with our browse exposure, so this is just an example of a yellow trumpet flower that's exposed. Some of these are a little difficult to put in. I really wanted to use T-posts and panels, but I was not going to be able to pound those into the ground, so instead we used rebar chicken wire, and it worked out okay. So this is just kind of an example of a picture. It's kind of hard to tell, but right where that tape ends is like right where that new growth started. So I would do that for, I did 30 stems on each plant, and just kind of went all around that plant to see, all right, how much growth did we get from this year? And then one big portion that we're including that the Creech team in Nevada or in the Mojave Desert did not include is density dependence. We're gonna investigate this and see if we can find it. We think that it's gonna be there, we just have to wait and see. So I'm looking at the relationship between fecal nitrogen, collecting all these fecal samples from deer and sheep and seeing what's that nitrogen content. So I'm gonna use that kind of as an indication of how healthy these animals are. So what's going in and what's coming out, right? So looking at fecal nitrogen in relation to MSAVI, so what's on the ground and how much of that are they taking in? So kind of like a nutritional performance indicator. So we have that, we know what that's gonna look like, or we know that we can put those two together. However, we also wanna see what this looks like. What happens when you take sheep off the mountain? So what happens when you have a high density of sheep and then a low density of sheep? So we just translocated 77 sheep to the Franklin Mountains in December. That was successful. So that was right before December, that was our high density population. Now that we've pulled those sheep off, now we're in a low density population. And I'm gonna continue to collect these fecal samples through October to see how that difference between fecal nitrogen and MSAVI changes after we've taken off those sheep. So I'm a master's student and I have 2 years. So I'm just trying to kind of build a framework. However, this is what I'm trying to build, is this carrying capacity framework. So looking at fecal nitrogen on that y-axis there, and then your MSAVI on the x-axis, what we kind of expect is this relationship between the two. Pre-translocation, it's going to be a decently even slope, or whatever you want to call it. But after that translocation, we're expecting that relationship is going to be really steep. So you have fewer mouths to feed on the landscape, right? So they're going to be taking in higher quality forage because there's more of that to go around with fewer mouths to feed. So with that, we expect their fecal nitrogen to kind of jump up. But I can only give you those 2. So what we're going to have to do is then we're going to have to continue this and keep collecting fecal samples and MSAVI data over the next 2 years and fill in these gaps. What happens in between that translocation and the next translocation. So this will be previous work, but this is what I can give you right now, or by the time I'm done. Looking at it in a little more 3D space, so if I have fecal nitrogen in my population size and MSAVI, that blue plane that's kind of going through the flat there. What we're kind of looking at that is kind of like our maintenance level. So what is the lowest amount of nitrogen that we would see in fecal nitrogen? What's that maintenance level? What is the minimum food for these sheep and deer would need? So if I flip that all around, so it looks like this, and then we get a little prettier. What we're kind of looking at is what is our IMSABI on the bottom, and then what is our population there on the x-axis or the y-axis. So what we're kind of hoping is that once I get all this data together, we can look at a value of IMSABI over the last 6 months, the last year, and say, okay, this is where our IMSABI for the properties is right now. Based on that number, this is about how many animals we think that the property can support. So we've used 160 animals, but we want to see, we don't really narrow that in with varying conditions from year to year. Based on this number from IMSABI, from satellite imagery, how many sheep do we think we can support? So, currently, I have 778 fecal samples. I'm going to be sending those to Dairy One Labs up in Maine. They're going to do my fecal nitrogen assessment, and they're going to tell me how much nitrogen is in each of these samples. My vegetation sampling is done. I don't have to do that anymore, which is great. So I'm still working on the analysis for that. I'm hoping to get that done this summer as well. And then this picture here on the right, as you can see that the amount of grain on that picture is changing. That's just kind of a GIF of all these different images of IMSABI from March of 2023 to February of 2025. So you can see how that green up changes over the landscape through those different months. So just to kind of dive into that a little bit more, for my fecal samples, as I told you, I've got 778 of them. When I'm out there getting fecal samples, I really need to know, did this come from a deer or did this come from a sheep? If I don't know, then that sample's kind of useless to me. So I watch butts for a very long time. And I actually try and watch fecal pellets fall from an animal, so I know if that sample came from a deer or that sample came from a sheep. So while I'm doing that, I'm also just trying to collect any other information that I can. It's not necessarily helpful to my thesis question, but it's kind of interesting to know. So if I can tell, like if I'm close enough that I can tell whether it's male or female, I write that down. So far I have 287 samples that I know came from males, 73 that I know came from females, and then I also, we had 30 sheep and 24 deer collared in March of 23, and I kind of use that to help me get, to kind of follow these animals around and get samples when I could. At least, where are they on the landscape? So from those, sometimes I was able to say, oh, there's tag 57, they just left me a sample, and I was able to say, this sample came directly from this known individual. So out of those, I collected at least one, usually multiple samples from 8 rams, 5 ewes, 8 bucks, and 4 does. Those collars have since dropped off. They dropped off in April, so my job's gotten a little bit harder, but that's okay. I at least have kind of an idea of where they've been going based on that GPS data, and I can continue to use that, just kind of seeing where they were at this time last year, the year before. So this is just kind of an example of what my sample bags look like. I collect them in a roll pack, and then I put them in these brown paper bags. They go in this big old giant oven. I dry them, I grind them up, and then I'm going to send them out, and somebody else will actually tell me how much nitrogen is in there. As far as my vegetation plots go, so again, these are those 30 meter by 30 meter plots. And sorry, I failed to tell you guys, so 30 meters by 30 meters, we chose that size because that lines up directly with what a satellite image pixel, or like a 30 meter by 30 meter satellite image pixel. So exactly what's in this one pixel, I'm gonna be able to look at look down on the ground and be like, what exactly was in that pixel based on, and compare that with that reading I got in that satellite image. So out of all my vegetation plots over the 2 years, I've observed 49 species. Our most observed species were Mariola, skeleton leaf goldeneye, oregano, and catclaw. Our least observed bees, each one of them I only saw one. We had Royal Croton, Highland English, honey mesquite, and mountain laurel. That doesn't mean there's only one of those plants on the whole mountain. It's just all I saw out of all of the plants that I looked at in each of my points in each of my plots. As far as my browse surveys go, out of the 100 plants that I sampled, or excuse me, so 50 plants, but I had 2 of them, so I had 100 plants. Out of that, we saw 15 or 14 species. Adelphia was the highest, Royal Croton, and Clifton, Bush, and Evergreen sumac were the lowest. But this is just all the species that I had and how many of them I had over this landscape there. As as far as my next step goes, I still need to collect fecal samples until October. The reason that we are choosing by October is like my dead date. October is kind of like the best month out of the year where we see the most green up and the vegetation's best. It's post-monsoon. So I collected samples starting in August of 2023, collected those all the way up to December of 2024, pre-translocation, where we had our high density population of sheep. Now that we've moved sheep off, I've collected samples through the rest of those months, the lean months and the better quality vegetation months. So through October, I'm going to keep collecting those samples. We did hire an undergraduate this semester, his name is Posada, and he's helping me immensely with not only collecting all these samples, but he is the one that's putting the time in the lab, drying all these samples, grinding them up, and packaging them so we can send them out. Statistical analyses on my vegetation sampling coming this summer. I'm going to be using some principal component analyses to look at my veg plots and compare that with my satellite imagery. And then I just have to write a thesis, so that shouldn't be bad, right? Maybe. But going forward from this project, so right now we're just looking at Elephant Mountain. I have the veg data, we have the MSAVI data, and I have the fecal nitrogen data from this area. So we're going to build this framework. We're going to keep collecting data, and we're hopefully by then it's going to have a product that we can go to TBS and say, hey, based on what MSAVI is looking like, this is how many sheep we think you can support, and then they can go and make their decisions as far as when do they need to translocate, how many can they pull off. Hopefully we can help them out a little bit. However, this doesn't have to be just for elephant. We could do this other places. We've had satellite imagery going back to like the 70s. Like we can do this. We can do this on transphasics. We can do it for other species. All we need is more poop. That's pretty much it. Anyways, that is kind of where I'm at and where I'm going with this project. I plan on being done kind of around December. We'll see what happens. Thank you guys for being here and listening to my talk. Thank you to all of the members and sponsors on this project. You guys have any questions? Okay.
Hailey, not knowing hardly anything about bighorn diet, you know, when you're doing browse samples, and will they switch back and forth, you know, between browse, forbs, and weeds, and grass, you know, like say an axis, or, I mean, they kind of, you know, multi-digested, where they can, you know, take, I mean, regular sheep, they won't browse. But, so what percentage, I mean, it'd be different times of the year, but can they survive just as well on forbs and weeds and browse?
So the reason I'm specifically looking at browse, this is an excellent question, because yes, they can and they do eat different things. However, you have to think about what is available to them at certain times of the year. So after the rains, we're going to have a lot of grass, we're going to have a lot of forbs, right? However, December, January, all those grasses just nest, they all die. And so there's not a lot of grass in their diet that's really actually giving them any like quality nutrition. So we're looking at browse species because those are available to them year round. They can eat on them in July, they can eat on them in December. They're probably going to eat more so of those temporally available things. So like they're maybe going to eat grass more in June, July, and August, and they're not going to eat so many browse species during that time. But their diet is varied, but we focus on browse because that's what's available all the way to them.
So unlike whitetails, they can digest grass.
Mm-hmm.
Okay. Have you ever done any, you know, some acidity assessments of some content?
I have not. I know there's a lot of papers out there that have, but I'm not really looking at that for this stuff.
Done some